Hey, so this is section 3.2, which we've already covered mostly. I just wanted to go over a couple of more examples. So for example number 2, we're asked to find y prime and y double prime, so the first and second derivative. First derivative, we just use product rule. And here's the product rule. This here, our f is e to the x, and our g is the square root of x. So if we do f times the derivative of g, so the derivative of the square root of x is 1/2 x to the negative 1/2, and then plus f prime, so the derivative of e to the x is still e to the x, times g, which is x to the 1/2. Now I'm writing it x to the 1/2 instead of the square root of x because I'm going to take the second derivative. So this is the first derivative. Second derivative, now we have to apply product rule again. So I'm going to highlight these guys. Those are the two things that we're taking the product of. The 1/2 we can factor out. And then we're going to do the e to the x, that's f, times g prime. So that's going to be times negative 1/2 x to the negative 1/2 minus 1, which is negative 3/2, plus derivative of e to the x, which is still e to the x, times g, which is 1/2 x to the negative 1/2. Now we're going to do, this piece right here is all this right here. So then for the second part, we're going to take the derivative of this product, and then that's going to give us plus e to the x times the derivative of x to the 1/2, which is 1/2 x to the negative 1/2, plus derivative of e to the x, which is e to the x still, times just x to the 1/2. So that right there is our green. And then we just need to clean this up a little bit. So we're going to have second derivative. If I distribute that 1/2, I'm going to get negative 1/4 e to the x, x to the negative 3/2, plus 1/2, whoops, it's 1/4 e to the x, x to the negative 1/2, plus 1/2 e to the x, x to the negative 1/2, plus e to the x, x to the positive 1/2. And let's see if we have anything in common. I think we can combine these two together. Those are like terms. And we could probably factor out we can definitely factor out an e to the x, and we'll do that. It's in every term, so we can go ahead and just factor out one of them. We could probably do more, but we don't necessarily have to. So let's go ahead and factor out the e to the x. And then we have negative 1/4 x to the negative 3/2. That's this piece. If we add these two together, we're going to have 3/4 x to the negative 1/2 plus x to the positive 1/2. And then if we want to follow follow suit here, our original had square root of x in it, so we'll go ahead and write those up like that. So e to the x times, I'm going to write this as negative 1/4 square root x cubed, or you could write x root x if you prefer, plus 3/4 square root x plus square root x. And there are different variations of that which would be acceptable, but that by itself is acceptable. The next example, find the equation of the tangent line at 3 comma 0.3 of the serpentine function. So if you graph this, then you'll see why it's called the serpentine function. It has kind of like this, a serpentine kind of shape. That's not a great rendition, but we can graph it in GeoGebra and look at our results. We'll do that afterwards. Okay, so we need, in order to find the tangent line, we're going to need a slope and a point. So we have the point, and we're going to get the slope by taking the derivative of our function and evaluating it at x equals 3, because that is the x value. So we're needing to find y prime of x first. So we've got low d high, so that's the 1 plus x squared, times the derivative of x, which is 1, minus high d low, so that's x, and then the derivative of 1 plus x squared is 2x, all over low low, so 1 plus x squared squared. Expanding this out, we don't really need to, do we? It might be helpful, but x squared plus 1 minus 2x squared over 1 plus x squared squared, which is 1 minus x squared over 1 plus x squared squared. We didn't need to do that because all we need to do is plug in the 3, and we could have plugged in the 3 anywhere, it doesn't matter, but that's going to be 1 minus 9 over 1 plus 9 squared. So that's negative 8 over 100. So there's our slope. And that's all we needed was y. Now we are using point slope. So y minus y1 equals m times the quantity x minus x1. So y minus y1 is 0.3. I'm getting that from our point here. Equals negative 8 100ths times x minus 3. So y equals negative, I'm going to go ahead and write this as 0.08 x. And then for this part, let's see, we have 0.08 times 3, that's going to be plus 24.24 plus 0.3. So y equals negative 0.8 x plus 0.54. And we'll check right now to see if that is accurate. I'm going to go ahead and graph it in GeoGebra. So let me see, y equals negative 0.08x plus 0.54. I need to write it down because I'm going to leave this page for a minute. And go ahead and go to the graphing calculator, get these guys out of here. And then we're going to put in our function, which was x over 1 plus x squared. There's our serpentine function. And then we are looking at the point 3, comma 0.3. Which I don't see because we're squeezed in too far. There's our point. There's our point A. And then we're going to put in the equation of the line that we found that should be tangent to this function at that point. So it's negative 0.08x plus 0.54. And you can see by the graph that we must have done it correctly, because that certainly looks tangent at that point. The next section is given that P of x is the product of f and g, and Q of x is the quotient of f and g, then we're being asked to find these two things. So P prime at 2. So P prime at 2 is going to be from the product rule. So if this is our product, then we're going to have f times g prime plus f prime times g. And evaluated at 2 means we're evaluating each of these at 2. Okay, so we need what all these things are. So f of 2, that one's easy. We go to where x equals 2, and we go to f, and the value is 3. The next one for g prime of 2. So here, oh, well, g prime, okay, means the derivative. So g prime at 2. Now notice g at 2 is linear, and so we can find what g prime is by looking at the slope of this line right here, and it's going up 1 over 2. So g prime evaluated at 2 is just 2. F prime at 2. Similarly, we're going to go look at this point here, and you can see that the derivative is 0. And then g of 2 is just the g value evaluated at 2, which in this case is 2. So if we put all these pieces together, P prime evaluated at 2 is going to be 3 times 2 plus 0 times 2, or 6. Similarly, to find Q prime of 7, we just need to use the quotient rule. So that's going to be low d high, so g f prime minus high d low, so that's f g prime, and then over g squared. So we're going to need f of 7, and I need to erase this stuff. This was from earlier. Oops, sorry. Okay, so we need g of 7. You should get 5. That's from looking at 7 and then going up to g and then noticing that that's 5. We need f prime at 7. So here we need the tangent at this point, which I don't think is obvious, but we can guess at it. So the slope of this line here, let me erase it so we can see it again. Tangent here. I'd be willing to say that that's a slope of -1. Then g evaluated at 7 is going to be 1, and you can see that here from the graph. And then g prime evaluated at 7, That one, again, is coming from a linear function. So we can see that this right here is a line with a slope of negative, let's see, negative 2/3. And so at 7, the slope of the derivative is also negative 2/3. So now we can just plug into, so q prime of 7. I'm going to use approximately because this slope here was approximated. So let's see, we have g of 1, or g of 7, which is 1, times f prime at 7, which is negative 1, minus f at 7, which is 5, times g prime at 7, which is negative 2/3, all over g squared. Let's see, so g, we actually probably need to come up with the equation of g. So let's take a look at g. We have a slope of negative 2/3. And then if we want to just use another point, we can just use the point 7, 1. So y minus 1 equals negative 2/3 times x minus 7. So we'll solve this for y. Negative 2/3 x plus 14/3 plus 1. This will be 17/3. So let's go ahead and write this as 17/3 minus 2/3 x. Again, evaluated at 7, which is really dumb. Okay, so what I just did was like stupid because I didn't need to do all that. I just needed g prime at, let's see, what did I need here? Low. So we just needed, actually, this low was g evaluated at 2 squared. So really this can just be 4. So q prime of 7 is approximately, we've got negative 1 plus 10/3 all over 4, which is 7/3 times 1/4, which is 7 over 12. Okay, and that finishes up this section. The next section we'll do is this is section 3.2.